Greetings, stargazers. Have you ever looked up at the night sky and felt a sense of wonder? The stars above, twinkling like celestial fireflies, have captivated humanity for millennia. Each star is a cosmic engine, a fiery furnace that burns for millions, even billions of years. In this grand cosmic ballet, stars are the dancers, twirling and swirling across the vast expanse of space. Understanding the life cycle of stars is akin to unlocking a fundamental truth about the universe itself. The night sky tells a silent story, a narrative written in the language of starlight. Each twinkling point of light represents a different chapter in this grand cosmic tale. Some stars are young and vibrant, burning with the intensity of 1,000 suns. Others are nearing the end of their lives, their light dimming as they prepare for their final act. To truly comprehend the universe, we must delve into the heart of these stars. It is a journey that will take us to the edge of scientific understanding, where gravity and nuclear fusion engage in a delicate dance. Unveiling the mysteries of star life cycles is a challenge that has captivated astronomers for centuries. Stars live for incredibly long periods, far beyond the scope of human lifespans. Observing their entire life cycle directly is simply impossible. However, by studying a multitude of stars at different stages of their lives, astronomers have pieced together a comprehensive understanding of their evolution. Like detectives at a cosmic crime scene, scientists analyze the light emitted by stars, their temperature, and their gravitational pull. This data allows them to reconstruct the life story of these celestial giants, from their fiery births in nebulae to their dramatic deaths. Our story begins in the cold, dark depths of space, within vast clouds of gas and dust known as nebulae. These cosmic nurseries, often spanning hundreds of light years across, are the birthplaces of stars. Imagine a swirling vortex of hydrogen, helium, and trace amounts of other elements, all drawn together by the relentless pull of gravity. Within these turbulent clouds, pockets of denser material begin to clump together like seeds scattered across a cosmic field. As more material falls inward, the temperature at the center of the clump begins to rise. The nebula, once a serene cloud of gas and dust, becomes a crucible of creation. A slow awakening, the protostar's journey. As the central region of the collapsing cloud heats up, it begins to glow faintly, emitting infrared radiation. This glowing core, still shrouded in a veil of gas and dust, is known as a protostar. The protostar, though not yet a true star, exerts a powerful gravitational pull on its surroundings. It continues to draw in material from the surrounding nebula, growing larger and hotter over time. Sometimes the infalling material forms a swirling disk around the protostar, known as a protoplanetary disk. Ignition, the birth of a star. The protostar's core continues to contract and heat up under the relentless force of gravity. Finally, when the core reaches a scorching 10 million degrees Celsius, a magical transformation occurs. Hydrogen atoms fuse, creating helium and releasing an enormous amount of energy. This is nuclear fusion, the very process that powers the stars, including our own sun. At this moment, the protostar ceases to be a protostar and emerges as a true star. The main sequence, a star's prime time. Having achieved nuclear fusion in its core, our star now enters what astronomers call the main sequence. This is the longest and most stable period of a star's life, a time of relative equilibrium. Think of it as the star's adulthood, a period of steady, reliable energy production. Our Sun, a typical main sequence star, has been shining brightly for about 4.6 billion years. During this time, it will continue to fuse hydrogen into helium in its core, releasing a constant stream of energy. The life of a star is a constant battle between two fundamental forces, gravity and nuclear fusion. Gravity tries to pull all of a star's material towards its center, attempting to crush it into oblivion. Opposing this inward force is the outward pressure generated by nuclear fusion in the star's core. This delicate balance determines a star's size, temperature, and ultimately, its fate. For stars on the main sequence, like our Sun, this balance is maintained for eons. However, as a star ages and consumes more of its hydrogen fuel, this balance begins to shift. As the core contracts and heats up, a shell of hydrogen surrounding the core ignites, fusing into helium at an accelerated rate. This increased energy output causes the star's outer layers to expand and cool, transforming it into a much larger and cooler red giant. This transformation into a red giant marks a turning point in a star's life. It's a sign that the star is approaching its twilight years, that its days of stable hydrogen fusion are coming to an end. Low-mass stars like our Sun will eventually shed their outer layers, leaving behind a dense Earth-sized core known as a white dwarf. For massive stars, the red giant phase is just a prelude to a far more dramatic fate. This phase marks the beginning of the end for these colossal entities. As these stellar behemoths continue to fuse heavier elements in their cores, they undergo significant changes. They are essentially racing against time, evolving rapidly through their life stages. Each successive fusion reaction releases less energy than the last, causing the star to lose its brilliance. It's like a fire slowly running out of fuel, struggling to keep burning. The core, now a dense ball of carbon and oxygen, becomes increasingly unstable. It continues to contract and heat up, reaching extreme temperatures. Desperately trying to ignite the next stage of fusion, the star fights a losing battle. Fusing elements heavier than iron requires energy rather than releasing it. The core, now at its limit, is no longer able to support itself against the crushing weight of its own gravity, leading to an inevitable collapse. It begins to collapse in on itself, marking the final moments of the star's life. Supernova, the explosive death of a giant. The core's collapse happens in a fraction of a second, faster than the blink of an eye. The inward rushing material rebounds off the incredibly dense core, creating a shockwave that propagates outwards at nearly the speed of light. This shockwave tears through the star's outer layers, igniting a runaway nuclear fusion reaction that consumes the remaining fuel in a blinding flash of light. This is a supernova, the explosive death of a giant star. The shockwave from the supernova blasts the star's outer layers into space, seeding the surrounding interstellar medium with heavy elements. Stellar remnants, ashes to ashes, dust to dust. In the aftermath of a supernova, the core of the star remains, but it's no longer the fiery furnace it once was. The intense pressure from the supernova explosion has compressed the core into one of two possible exotic objects, a neutron star or a black hole. Neutron stars are composed almost entirely of neutrons, subatomic particles packed together with unimaginable density. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. They are cosmic abysses, the ultimate endpoints of matter and energy, shrouded in mystery and forever hidden from our view. Black holes, gravity's ultimate triumph. Imagine a place where gravity reigns supreme, a place where the very fabric of space-time is stretched and torn. This is a black hole, the ultimate triumph of gravity over matter. Formed from the collapsed cores of the most massive stars, black holes are objects of extreme density, places where the laws of physics as we know them break down. Their gravitational pull is so strong that nothing, not even light, can escape their grasp. As matter falls into a black hole, it forms a swirling disk of superheated gas known as an accretion disk. Neutron stars, cosmic lighthouses. While some stellar remnants collapse into black holes, others find a different fate. Neutron stars, the remnants of stars not quite massive enough to form black holes, are equally bizarre and fascinating objects. Imagine compressing the mass of our Sun into a sphere the size of a city. These stellar corpses are composed almost entirely of neutrons, subatomic particles packed together with unimaginable density. Neutron stars are not only incredibly dense, but also incredibly hot and magnetic. They spin rapidly, often hundreds of times per second, emitting beams of radiation from their poles. Recycling the cosmos from death comes life. The death of a star, whether through a gentle fade-out or a cataclysmic supernova, is not the end of the story. The material blasted into space by supernovae, enriched with heavy elements forged in the hearts of dying stars, becomes the raw material for new generations of stars and planets. These stellar nurseries, seeded with the ashes of their predecessors, will eventually give rise to new solar systems, perhaps even harboring life on distant worlds. Our own solar system, including our Sun and Earth, owes its existence to this cosmic recycling process. We are quite literally stardust. A universe in perpetual motion. The life cycle of stars is a testament to the interconnectedness of the cosmos, a grand cosmic dance of creation and destruction that has been playing out for billions of years. From the birth of stars in swirling clouds of gas and dust to their explosive deaths as supernovae, the universe is in a perpetual state of motion, constantly evolving and transforming. Understanding the life cycle of stars allows us to trace our own cosmic origins, to see ourselves as part of something far grander and more awe-inspiring than we could have ever imagined. Our journey through the life cycle of stars has taken us from the vast, cold clouds of interstellar space to the unimaginable heat and density of stellar cores. We've witnessed the birth of stars in swirling nebulae, their long and steady lives on the main sequence and their dramatic deaths as supernovae. We've explored the bizarre remnants of these stellar giants, from rapidly spinning neutron stars to enigmatic black holes. The life cycle of stars offers us a profound cosmic perspective. We are, after all, stardust, forged in the hearts of stars that lived and died long before our Sun ignited. Stars are more than just celestial objects. They are the luminous beacons of the night sky, guiding us through the darkness and inspiring wonder and curiosity. They are the architects of the universe, shaping the cosmos with their energy and their remnants. Through their life cycles, stars influence the formation and evolution of galaxies. The heavy elements forged in their cores, from carbon to iron to gold, are the building blocks of planets, of life itself. These elements are essential for the development of complex molecules and biological systems. The very air we breathe, the water we drink, the ground we walk on, all were once part of stars that burned brightly billions of years ago. Our planet and everything on it are products of stellar processes. Their deaths, often spectacular and violent, seed the interstellar medium with these elements, enriching the cosmic soup from which new generations of stars and planets will form. This cycle of death and rebirth is fundamental to the universe. This cosmic recycling process ensures that the universe is a dynamic, ever-evolving place where death and creation are inextricably intertwined. It is a testament to the interconnectedness of all things in the cosmos. The legacy of stars extends far beyond their individual lifespans. Their influence can be seen in the formation of new stars, planets, and even life forms. It is woven into the very fabric of the cosmos, a continuous thread that connects the past, present, and future of the universe. As we gaze up at the night sky, we are witnessing the culmination of billions of years of cosmic evolution. Each star, a distant sun, tells a story of birth, life, and death, a story that is both unique and universal. Understanding the life cycle of stars allows us to place ourselves within this grand cosmic tapestry. It reminds us that we are part of something far grander and more awe-inspiring than we could have ever imagined. It humbles us, yet it also empowers us. For in the face of such vastness, we are challenged to explore, to discover, to unravel the mysteries of the universe and our place within it. The universe is a vast and mysterious place, filled with wonders that we are only just beginning to uncover. Every corner of the cosmos holds secrets that challenge our understanding and inspire our imagination. The life cycle of stars is just one chapter in this grand cosmic story. From their birth in nebulae to their explosive deaths as supernovae, stars play a crucial role in the evolution of the universe. There are countless other mysteries out there waiting to be explored, from the elusive nature of dark matter and dark energy to the tantalizing possibility of life beyond Earth. Each discovery brings us one step closer to understanding the fabric of reality. So keep looking up at the stars and never stop asking questions. The night sky is a canvas of endless possibilities, inviting us to ponder our place in the universe. For it is in our nature as human beings to explore, to discover, to push the boundaries of our knowledge and understanding. Our curiosity drives us to venture into the unknown, seeking answers to the most profound questions. And who knows what wonders we might find, what secrets the universe might reveal if we dare to keep searching. The cosmos is a treasure trove of marvels waiting for those bold enough to seek them out. I hope this exploration of the stars has ignited a spark of curiosity within you. Let that spark grow into a flame of wonder and discovery. If you'd like to delve deeper into the cosmos, check out my other videos on this channel. Each video is a journey into the unknown, offering new insights and perspectives. And don't forget to share your thoughts and questions in the comments section below. Your curiosity and insights are what make this community vibrant and engaging. Let's keep exploring the universe together. There's so much more to discover, and the journey is just as important as the destination. Until next time, keep looking up. The universe is vast and our adventure has only just begun. Kindly like, share and subscribe for more.